Hello everyone, welcome to this video. In this video, let us get into the next concepts of module 5, that is first generation technology and second generation technology. What is first generation technology? This first generation technology is generally called as 1G in wireless telecommunication technologies. We will be having 1G up to 5G. So out of these generations, we will be having the first generation that will be represented as 1G. In this 1G, the concept of cell phones comes into picture. 1979 is the year where first generation is started to evolve. Means wireless telecommunication technology started to evolve in 1979. So in this 1979, once the concept of cell phone and the communication between the two parties through wireless media is going to have a technology called mobile telephone system. They will be having a method to establish a call between the two parties that will be called as mobile telephone system. This mobile telephone system is improved as advanced mobile telephone system that will be called as AMTS. This AMTS is again improved, will be called as improved mobile telephone service, that is IMTS. And then the next version will be called as PTT, that is push to talk. So out of this, AMTS is one of the important technology here we need to understand to get to know what actually 1G is give the service. So in this 1G wireless technology, analog signal will be used to transmit from person A to person B. Means the communication is going to happen through radio signals since it is a wireless communication. The communication which is happening is of purely analog signals. So we say analog radio signals are going to be used in this communication. Since it is going to allow only voice signal to transmit, there is no data transmission is allowed in 1G. The technology which is supporting only the voice communication between the two parties. So this voice communication will need to be modulated. Why? Because this voice will be an person audio. Audio signal will be in the range of 20 Hz to 20 kHz. As we know, this frequency ranges will be called as low frequencies. So low frequency signals will not transmit to the longer distance. So what the method we are going to use, that is modulation. So in modulation, we are going to use a carrier signal. So that carrier signal will be having a high frequency. That high frequency signal is up to 150 MHz is used in 1G technology. Here voice call gets modulated to a higher frequency of about 150 MHz and that is transmitted from person A to person B through a base station that will be called as generally tower. So these two towers are going to communicate using a radio signals which is modulated of 150 MHz signal. And this technique is going to use the multiple access technique, that is Fdma. In the previous video, we have seen three multiple access techniques. One is Fdma, another one is TDMA, another one is CDMA. So here Fdma is frequency division multiple access. In frequency division multiple access, if there are 10 people need to be started to establish a call, 10 frequencies are going to be allocated. So these 10 frequencies are different from one person to other person. This will be called as frequency division. We will be having a bandwidth of this much from something like 10 MHz to 100 MHz. We are going to divide these frequencies into different components and these frequency will be allocated to the first person, this will be allocated to the second, this will be allocated to the third. Likewise, we are going to divide the available bandwidth. That method will be called as frequency division multiple access. This is the technique we are going to use in 1G technology. Only voice communication is going to happen. What are all the disadvantages then? Only voice transmission is allowed, but there is no data transmission allowed in first generation. And the next thing is that it will be having low capacity. It is unreliable handoff. Handoff is the cellular concept we have discussed in the previous video. What do you mean by handoff means? If person A is at cell A and he is moving to cell B, while traveling from cell A to cell B, there will be a chance of handoff. Handoff in the sense, the channel which is allocated from cell A need to be released and one more channel need to be allocated from cell B. The two channels are different here. Cell A will be having its own channels, cell B will be having its own channels, means the frequencies. cell A to cell B the person is moving means when a call is established, he has to give back the channel which is allocated in cell A while he is traveling to cell B. So unreliable handoff in the sense the call will be disconnected while traveling from cell A to cell B. That is unreliable. Reliable handoff in the sense there should not be call disconnected at all. Easy handoff or the soft handoff we are going to say, that will be not possible in 1G. And poor voice links. The voice communication which is happening in 1G is of poor kind. The voice is not at all clear in this technology. And there is no security also. There is no security in the sense voice calls can be playback in radio towers. We will be having a connectivity to the base station. Through the base station we will be having a communication between person A and person B. So anyone can listen to the audio which is the person A and B are communicating while sitting in the base stations. That is what we call it as eavesdropping. Here eavesdropping in the sense secretly listening to a conversation. This can happen in 1G. This is the major disadvantage we can say in the 1G technology. So let us understand the method they are adopted in 1G, that is AMPS, that is Advanced Mobile Phone System. This AMPS is used in North America. In AMPS they are going to use 800 MHz ISM band. This ISM stands for Industrial Specific Medical Purpose they are going to use. That's why they have named it as ISM. Why it is 800 MHz means we know that there is an uplink as well as downlink. While mobile phone is sending the signal to the tower or the base station, we call it as uplink. And when the base station is transmitting some signal to the mobile phone, we call it as downlink. For uplink as well as downlink, we are going to use the frequencies in between in the range of 800 MHz. So here you can see the forward communication from base station to mobile station uses the band from 869 to 894 MHz. So 869 to 894 in the sense we will be having a bandwidth of 25 MHz. If you subtract 894 MHz minus 869 MHz, we are going to get 25 MHz is the bandwidth. This is F2 minus F1 if we are going to do, we are going to get a bandwidth. This is the band we can say from 894 to 869 MHz we are going to use for downlink. Downlink in the sense it is the communication from base station to the mobile station. If we consider this as a base station and this as a mobile station, the signals which is transmitting from the base station to the mobile station will be called as downlink. So this downlink will be using 25 MHz of band. Similarly, to the communication from mobile station to the tower or to the base station, we call it as uplink. It will be having 25 MHz of bandwidth. This 25 MHz of bandwidth will be starting from 824 MHz to 849 MHz. Again here if you take the difference between these two, it will be 25 MHz. So 25 MHz is the bandwidth we will be having for uplink as well as downlink. And the channel spacing, if we have a 25 MHz of bandwidth and multiple channels we need to have in between, these channels will be having a spacing of 30 kHz. And how many number of channels we are going to get out of this means 832 channels we are going to get. How we are going to say it is 832 means if we have a 25 MHz of bandwidth, if we are going to divide this by 30 kHz, this is what the spacing in between the two channels, we are going to get 833 point something. So this will be round off to 832 channels, means 832 different frequencies we can allocate for the users. Out of this 832, there are two service providers here. So 416 channels are going to be allocated to the one service provider and other service provider is going to use 416 channels. Out of this 416, 12 are used for control channels in the sense to send and receive the control information, and 395 voice channels are going to be used for the communication. This is how AMTS is going to use the bandwidth of 25 MHz for uplink as well as 25 MHz for the downlink, which is in the megahertz range of 800 MHz. That will be called as ISM band. Why it is called as ISM band? In the sense that band of frequency they are using at earlier stage for industrial, scientific as well as medical purpose. This communication between the two parties, in the sense because of the industrial communication, because of the scientific communication, and in medical purpose they are using this bandwidths. That's why they have named it as ISM. And how many number of channels are there? Means 832. And those channels are going to be having different frequencies. They will be having a spacing or bandwidth of 30 kilohertz, we can say. You can see in this particular diagram, this is representing a frequency bands used in AMPS. This is what the mobile phone, and this is what the base station or the tower generally we say. So forward communication, in the sense tower to the mobile phone, we call it as downlink, or we can call it as a forward communication, which uses 869 to 894 megahertz of frequencies. This bandwidth will be of 25 megahertz. Similarly, reverse communication. Reverse communication, in the sense mobile phone to the base station. This will be having a frequencies of from 824 megahertz to 894 megahertz. This is again a bandwidth of 25 megahertz. Here you can observe these are the frequencies, you can say, or the multiple signals, you can say. These are having a spacing of 30 kilohertz. This is what the block diagram of AMPS communication between the mobile phone as well as the base station. And if you look at 1G, this 1G is going to use a multiple access technique called Fdma. Here you can observe this is mobile phone 1, this is mobile phone 2, this is 3. Similarly, we are having n users started to communicate. What do you mean by this 3 kilohertz? In the sense the audio signal which is allowed in 1G, which is transmitting or which is generated in mobile phone, will be having a range of 300 to 3300 hertz. So this is what the range of voice signals we are going to say. So this voice signal or the voice which is generated in a mobile phone will be in this range. If you subtract this 3300 hertz minus 300, we are going to get the difference of 3 kilohertz. This 3 kilohertz is the bandwidth of the voice signal. So whatever the voice generated from the mobile phone will be having a frequency of between 300 to 3300 hertz. That will be the range will be having 3 kilohertz. This is the bandwidth. That's why here we are representing it as 3 kilohertz voice and 10 kbps control signal, in the sense this is for the control information. That's why here the method they are adopting for the modulation, that is FSK, frequency shift keying. This is of digital signal we can consider, and this voice signal is of analog type. Analog modulation technique is used, that is frequency modulation. And here the spacing between the channels you can observe, this is 30 kilohertz channel, this is 30 kilohertz channel, that is again 30 kilohertz they are mentioning here, which is of analog communication which are happening in these channels. And Fdma is the method we are going to use for the multiple access, and this Fdma is going to transmit to the tower or to the base station, or we can say BS. So this will be having a bandwidth of 25 megahertz. Why it is 25 megahertz? We will be having a downlink or uplink with a bandwidth of 25 megahertz. That is what the indication here. It is the output of Fdma through 25 megahertz band. This is what 1G technology is. It is going to transmit or allow us to have a communication with only voice. There is no data communication is allowed in 1G. There is no concept of image transfer in 1G. There is no concept of video in 1G. Only voice key is allowed to transmit from person A to person B through wireless media. Now let us see what is second generation technology. Second generation technology, in the sense it is generally called as 2G. Here in 2G, this is just an advanced methodology or advanced technology compared to 1G, where the analog communication is happening in 1G developed to digitized voice communication. The same voice communication which is happening in 1G is of analog type. Here in 2G, that is improved to a digital communication. Because of the digital communication evolvement, here we can expect text messages that will be called as SMS, a short message service, also allowed here, and also picture messages also we can send, and also some multimedia messages also we can transmit. In the second generation we can transmit voice. So this voice is also allowed in 1G. With that we will be having SMS as well as MMS facility to transmit the text, that is data, as well as pictures with MMS as a message. So these extra two facilities are going to be allowed in 2G with voice. That's why in 2G we are going to say with the current 1G technology, the additional two extra features we are going to get is SMS as well as MMS. But these communications are going to happen digitally. That is what the major change happened from analog in 1G to digital in 2G. This 2G cellular telecom network were commonly launched on GSM standard in Finland in 1991. 1G is coming to picture in 1979. After some 10-12 years, 2G comes into existence. In 1991 in Finland, they have used GSM standard. In this GSM standard, they have used over 2 billion people across more than 212 countries. More than 212 countries, around 2 billion people are going to use this 2G and in different territories. Because of that, different countries are going to involve in the communication. There will be a concept called roaming comes into existence. Means there is an international roaming that is allowed between the two users to communicate between the two countries, we can say. And then 2G can be divided into two standards based on the type of multiplexing. In 1G, you can recall Fdma is the technology we are going to use for the multiple access. Here TDMA and CDMA are the two methods that 2G is going to use for providing the multiple access. Since it is a digitized voice communication, digital communication comes into picture. There is a concept of codec is introduced. Codec in the sense compression and decompression algorithm. We can compress the data and decompress the data at the transmitter as well as receiver to have a multiplex digital voice data. This is the new method which is adopted in 2G. And 2G cell phone units were generally smaller than 1G units, and since they emit less radio power, consume less battery power also. And digital coding improves the voice clarity. That is the disadvantage in 1G you can observe. Voice clarity is also improved here and reduces the noise in the transmission line. Digital encryption techniques also used here to provide the security. What are all the limitations we have discussed in 1G are eliminated here or overcome using 2G, that is digitized voice communication. Here voice is clearly transmitted. It reduces the noise in the transmission line as well as the security is provided. Eavesdropping is avoided here. So that is what the security or the safety given to the data as well as the voice calls where the communication is going to happen. Here we need to understand the next version of AMPS, that is DAMPS. This DAMPS is the technology used in 2G system. What are the other methods used in 2G means IS-136, that is named as digital AMPS, that is DAMPS, IS-95, that is CDMA, and as well as GSM. These three are the techniques or the technologies come under 2G. In 1G we will be having AMPS, IMPS. Similarly in 2G we will be having DAMPS, CDMA as well as GSM. Let us understand DAMPS here. DAMPS is obviously a digital version of AMPS. That's why it is named as DAMPS. Here D stands for digital. And it is backward compatible with AMPS. What do you mean by backward compatible means? Whatever the technology AMPS is using, the same technology or the same method, this DAMPS is also compatible with. There is no need to change the device of 1G technology to adapt that to 2G. That is what the meaning of backward compatible. The new technology which comes into existence is supporting the previous technology system also. That is what the meaning of backward compatible. And it uses the same bands and the channels. What we have discussed in AMPS, the bands of 800 megahertz bands and the channels are the same channels we are going to use in DAMPS also. And it uses the frequency reuse factor of 1 divided by 7.25 frames per second. Here the concept of frames comes into picture. What do you mean by frame means? We have seen while discussing the concept of UART, communication interface, the concept of frame is discussed. where it will be having a data, it will be having a error correction code, it will be having a start bit, it will be having a stop bit, like that. So the packet, or it will be called as a frame, which will be having a data as well as the supporting bits. So concept of frame comes into existence when digital communication is started to evolve. So here each frame will be consisting of 1944 bits. The complete frame will be with 1944 bits. This is divided into 6 slots. This frame will be divided into 6 slots and shared by 3 channels. Each slot will be having 324 bits. 159 out of 324 bits, 159 bits are data and 64 are control information and 104 bits are error correction. If you are going to take 324 bits of one slot, we will be having 159 bits of data and 64 bits of control and 101 bits of error correction methods. So this is what the frame which a single channel is going to carry, and this is going to use TDMA as well as Fdma methods for multiple access. 1G is going to use only Fdma, but with that Fdma technique, TDMA is also introduced here. You can observe here in the AMPS block diagram, this Fdma is same as which is used in AMPS. At the initial stage, we need to convert the voice signal into the digital data. We will be having a digitizer here. Because of the digitizer, we are going to get the digital signals over here. So TDMA can be used. This TDMA is a method where the time slots are going to be allocated for the different persons or different signals. In one time, one communication is going to be happen. In the next time slot, the next communication is going to transmit. In the next time slot, the third communication is going to transmit. Similarly, it goes on. So TDMA is the method used at the first stage, and then QPSK is used. Here quadrature phase shift keying is the method used after TDMA signal. It is again 324 bits as we seen here. So QPSK output will be given to Fdma. Here also there will be QPSK, n number of signals which is coming as input to Fdma, and here only one signal is shown. So this Fdma methodology is same as AMPS, which is discussed in first generation technology, and again it is transmit for a uplink as well as whenever it is required for downlink, it is transmit as a 25 MHz band to the next level. This is what DAMPS is. Here in the second generation, we will be having TDMA as well as Fdma. This is what we need to remember. And in this second generation technology, we are going to use digital communication. The analog communication voice or the analog signal will be converted into digital signal. And in 1G, we will be having only Fdma, and we are going to transmit only voice. But in 2G, we can transmit voice, we can transmit SMS, we can also have image transferred, that is called as MMS. These are the extra facilities which is available in 2G. Only voice will be able to transmit in 1G. This uses Fdma, this uses TDMA as well as Fdma. And the other two techniques we have discussed DAMPS. The other two techniques are CDMA as well as GSM. In the next video, let us see what is GSM and how actually 2G is going to use the concept of GSM for mobile communication. Thank you.